Hello everyone. So here in this video we'll try to understand another searching algorithm which is binary search. So in binary search it's a repeatedly dividing search where a given array or a list is divided and it goes to the element which is in the center and checks if it is greater or not, and it goes likewise to the side which is closer to the searching element. Suppose you say in this given array, we are trying to find the element 91. So basically what this binary search will do is that it will go to the element which is at the center. So here at the center we have 23, right? So is 23 greater than 91 or lesser than 91? So we know that 23 is lesser than 91, right? So the next search will only happen in these indexes. So it will discard all these indexes and look through only these numbers. So once it comes to these numbers, so in these numbers, it will go to the element which is in center, that is 72. And it will compare if 72 is equal to 91. Since 91 is greater than 72, it will go to the arrays indexes which are greater than the present index. So it will go to 91 and 100. Here it will check if 91 is equal to the given element 91. And if it is, then it will return true, else it will return false. So let's take another example. Say it is searching for 5. Likewise, it will go to the center element 23. It will check if 5 is less than or equal to 23. Since 5 is less than 23, it will go to all those indexes which are lesser than the present one. And here it will check for the element which is at the center. And likewise, it will search for the elements which are to the left side, which are less than the present index. So here the time complexity becomes or big O of log n. That means every iteration we are reducing the size of the array, right? So the first iteration it was so much, then we only searched for half of it, then again we reduced the size. So that is why the time complexity here will be less than that of linear search. So let's start with the program. We'll start with including the libraries stdio.h, and we'll say void main. We have to go with I for the loop, then int, we'll initialize the array, and we need to find the size of the array, right? So size of array divided by size of the first element, right? Later we need the element that we're trying to find. X is equal to, let's say, 5 here. Then let's begin the searching, right? So here what all we need, let's try to um, use the iterative method here, and let's say that int result is equal to binary search function, wherein we are passing array and the initial index and the final index, and at the same time we are also passing the element that we are searching. And we'll say print, let's do that later, and let's define the function first. So here we are defining it. Okay, so here defining it, we start with int since the function is returning. So we'll say int binary search. What all we are getting? Int array. Then we are getting the index, right? So int, let's say left. We'll say int right, and also int value, the value that we're trying to find here. Okay, so here what is our condition here? till the left is less than or equal to right. That means in this condition, left is 91 and right is 100, right? So this condition will hold good. But what if we come to the end? That means that L is equal to 100 and also R is equal to 100 in the final and the worst scenario that we didn't find the element here. So here we'll say that if L is less than or equal to R, only then compare it, right? Because if the left side goes greater and right side comes here, that won't make sense because left has to be on the left side of right, right? So here we'll find the middle element. So we'll say L plus R minus 1 by 2. Here we need to have another bracket so that the code goes with this being executed first, later divided by 2 because of BODMAS rule. And we'll start with a condition. Say if you have divided the array to the required condition, and let's say that the element is already found, that say that the element that you found in the center 23 was the element that you're trying to find. That means if array of index m is equal to value, you say return the index, right? So you'll return the index. Suppose if array of m is less than the value that we're trying to find, well, that means here let's say the middle element is 23 and the element you're trying to find is 72, and since 72 is greater than 23, we have to put the left to the index which is after this middle element. That means that we are saying L is equal to middle element plus 1, else right should become less than the element that's at the center. So for the next condition, only these indexes will be compared, or else these will be compared rather than searching the entire array again, right? So suppose let's say that we have come to a condition wherein the value has become something like L is greater than R. That means we have not found the element, right? So let's say minus 1 in the return. So if result is not equal to minus 1, that means we have found the element, right? So let's say print element is found at index percentage %d result. And if the element is not found, we'll say printf element not found, right? So let's just try to run this program. Okay, so we are having an error here because we had to use an else statement, because this is being executed, but at the same time after this even this will be executed. So we have to say else and put this statement here and run it again. So element is found at index 1. So if you check here, 2 is at index 0 and 5 is at index 1, and we are trying to find the element 5. So we have found the answer. Let's say we are trying to find another element, suppose 91. See, it's at the index 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And let's try to find an element that is not there. You can see here the output says element is not found. So thank you.